All right, this is Algebra 1B Part 1, Unit 5, Lesson 3. We're continuing with quadratic equations. Quadratics, as you recall, are equations with x squared being the highest power in the expression. They're a polynomial expression. But we've learned to check solutions by substituting and simplifying to see if solutions work. Now we're going to work on solving them. I want to start with a simple example. X squared equals 144. Now you may recall your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and 14 squared is 196, 15 squared is 225, and 16 squared is 256. Okay. Likewise, the square roots work backwards, so the square root of 36 is 6. Square root of 36, not 63. 36 is 6. Okay, so you know your squares, you know your square roots. So we can recognize from inspection that x squared, the solution to x squared being 144, is x equals 12. However, 12 is not the only possible solution. If I take negative 12 and square it, that's negative 12 times negative 12, which is positive 144. So we always take the square root as plus or minus, positive or negative. That is, it's negative 12 or it's positive 12. There are two possible solutions. This is the root of why, the root, pun intended. This is the root of why there are multiple solutions, or two solutions typically, for quadratic equations. All right, so by inspection, knowing your perfect squares, you can figure out what squared, what number times itself equals 144. If you want to jot down these perfect squares on a sheet of paper or in your notebook, that wouldn't be a bad idea. Okay, so let's look at another one here. X squared equals 50. X squared equals 50. Now 50 is not one of my perfect squares. If you recall, if I took 7 squared, that was 49. And if I took 8 squared, that was 64. Now 50 is much closer to 49. So we say x is equal to plus or minus square root 50. That would be an exact solution. Or if we want an approximate solution, we use a wavy equal sign for approximately. Square root of 50, I'm going to guess, is somewhere close to 7, but closer to 7 than to 8, so maybe 7.1. Okay? If you want to check with a calculator, we can do that. Let's go to Desmos. And I don't think I have Desmos open, so let me open Desmos. Oh, Desmos! Come here, Desmos. Who's a good Desmos? Desmos.com/calculator. Here we go. Graphing calculator. Calculator, dude. All right. And to get a square root, you can type SQR, and you notice it's italics, but as soon as I hit the T, it puts the symbol in. Square root without the vowels. Square root of 50 is approximately 7.07. So to the tenths, I was correct. 7.1. Okay. So we can say x is approximately to the nearest hundredth 7.07, plus or minus, positive or negative. Okay. Exact solution, leave it the square root of 50. By the way, we do simplify square roots. We can simplify square roots. I'm not sure that is a topic of this lesson, so I won't go there right now. Square root 50 will do. And then approximate solutions. Not exact, because there is no exact solution to the square root of 50. It's an irrational number. Okay. And then finally, I want to look at one more case. What if we get this? What if we get a squared, an x squared equals a negative number like -4? You might be tempted to think, well, it's 2, because 2 squared is 4. But that's +4, not -4. Well, maybe it's -2, because -2 squared is -2 times -2. Wait a minute, a negative times a negative is a +4. So there is no way to square a negative number to get, or square a number to get a negative answer. A negative squared is positive, and a positive squared is positive. And so what we say here is this has no solution. No solution. It has no solution, and because we are trying to take the square root, plus or minus square root of a negative number, and you can't square root a negative number. No solution. Okay, so if you end up with that situation, immediately you know there's no solution. Okay, that said, let's go ahead and do a problem involving undoing. I did one in my last video like this, and I'll do one here like this too, just to review, because this is the primary topic of this lesson here. So undoing. Remember, we get the x alone, we do opposites to get rid of stuff, and we work backwards, SADMEP, and instead of PEMDAS, and we use opposites to get rid of things. All right. So here we have two sides of the equal sign. The 7's all by itself. We'd like to get the x by itself. Get the x alone. That's the first principle. Get rid of things. Remember the dog pile principle. When the fumble on the field and the football happens and people pile on top, who has to get off the pile first? But the last one off has to get off first. So here's x, the football. On piles the 2, on piles the squared, on piles the times 2, on piles the -11. -11 was the last one on, so it's got to come off first. The opposite of -11 is +11. Balance says we add 11 to both sides of the equation. We end up with 2 times x plus 2 squared equals 7 plus 11, 19. And then divide by 2, because this 2 is the last one on. Divide by 2. Okay. And we get x plus 2, quantity squared, equals 19 divided by 2. I'm going to go ahead and divide that by 2 and give a decimal answer. That's going to be 9.5. Okay. Yep. And actually, whoa, back up. 7 plus 11, you're probably screaming at the camera. 7 plus 11 is not 19. 7 plus 11 is 18. And that's going to work out much nicer. 18. 18 divided by 2 is 9. Much nicer. Yeah. Okay. And then we square root both sides. The opposite of squaring is square rooting. So x plus 2. We're going to square root both sides. And remember that there's a positive root and a negative root, so we go plus or minus. So x plus 2 equals plus or minus 3. I'm going to list them separately. I'm going to say -3 or +3 because the next step involves adding 2 to both sides. Add 2, add 2, add 2 to both solutions. It's like solving two equations at once. So x equals -3 plus 2 is -1. 3 plus 2 is 5. -1 or 5. Okay? And that's for one that turns out very nicely. -1 or 5 is the solution set. Let's try one that doesn't turn out so nicely. Let's change colors here. And let's go x plus 3, quantity squared, plus 15 equals 72. And that is a 3, not a 5. Okay, so again, we're going to solve the equation by obeying the rules of solving an equation, by undoing. Get the x alone, get rid of things by doing opposites or inverse operations. Work in reverse order, balance, do the same thing to both sides. So minus 15. We start with the 15 because it's farthest away. Minus 15. X plus 3 squared. 70, 60, and 57. Track that out here again. 50, 60, 72. Yep. Okay. Opposite of squaring is square root. When you square root, you get a plus or minus. Plus or minus square root. And square root of 57 is one of those that falls in between the cracks. X plus 3 equals square root of 57. So I'm just going to say plus or minus square root 57 for now. And then we go minus 3 to both sides. And here's how we write the solution in this case. If you're asked to write the solution in exact form, we write the minus 3 first. X equals minus 3 plus or minus square root 57. Now if you're asked to estimate or round the answer, or give an approximate answer, then what you do is you estimate the square root of 57. You can do that in your head this way. 7 times 7 is 49. 8 times 8 is 64. So 7 times 7 is 49. 8 times 8 is 64. 57 lies, 7 away from 64 and 9 away from, so it's closer to the 8 than to the 7. So I'm going to estimate about 7.6. Okay, so negative 3 plus or minus 7.6. So negative 3 plus 7.6, negative 3 plus 7.6, or negative 3 minus 7.6. I get negative 10.6, or negative, negative 3 plus 7 plus 7.6, you got to subtract, is 4.6, or negative 10.6. And we'd say x is approximately. Okay, and we can check it with our calculator, get a better answer, a more accurate answer than this. You can answer the whole thing here. You can enter negative 3 minus square root 57 and 10.5. Yeah, so 10.5 is a better answer than 10.6. That was because I estimated in my head. It was off by a tenth. Negative 3 plus square root 57 and positive 4.5. Yeah, 4.5 is closer than 4.6. Okay, and you can round to whatever significance you need for that particular problem. All right, I think that's enough for now.